Okay, now that you've gotten some of the general idea from playing around with the projecting on the masks activity, let's really nail down some of these characteristics. So we have a definition here. A dilation is a transformation that changes the size but not the shape of the image. Then we have something called the scale factor, which measures how much larger or smaller the image is. So this picture down here is an example of a dilation, and I want to break down some of the things that we see here. Give you some quick vocab words. We have something called the center of dilation, or sometimes just the center. This was the projector in our mask projection project. We have our pre-image. And then we have the image. Notice that in the pre-image, the letters are A, B, and C, but in the pre-image, they're A prime, B prime, C prime. Those tick marks let us know that it's the new one, not the original. Something else that we want to look at in this diagram is something that's true of all dilations. These dotted lines that you see going from the center to each point exist in all dilations. You might have come across this when you were doing your mask project, if you ever looked at the shadow to make sure you were lined up. Because every point in your mask or your image had a corresponding point that was in a line with the projector, or original, and projected image. They all lined up. So, like I just said, the shadow of the mask would line up with the projected image in the same spot. Some other things that might be helpful to connect back to the masks. The pre-image was either the transparency or the picture from the computer. And then the image was the mask projection. So let's talk about that word scale factor, or term scale factor. That's the how much for the size change. Now, one thing that we need to be very clear about here, dilations are multiplicative. So the scale factor is either something that we multiply or divide. So, thinking about that, things that we usually use with multiplication and division, we have fractions, ratios, and percents. All of those can summarize a multiplicative relationship. So to make this a little bit more concrete, here's a couple of examples. We have a scale factor of 2, where everything in this image has been enlarged by a factor of 2. So this side is now twice as long, this side is twice as long, etc. And if we look at the second example with a scale factor of 1/2, we're going to go the opposite. Everything that corresponds is now being divided in half, or multiplied by 1/2. So when we have scale factors that are greater than 1, we get bigger. I use the letters SF to represent scale factor. If the scale factor is greater than 1, it gets bigger. If the scale factor is less than 1, it's going to shrink. So the shape of the projected face needed to be the same, just smaller than the mask. So you might have noticed that if the eyes were too wide apart in your projected image, or the face you were projecting, it wouldn't line up with the projected image. This is because even though we have a scale factor, that only affects the size. It doesn't affect the shape. So let me just add some notes here, some general things that you need to know. Only size affected, not shape. So what does that mean? What does shape mean? That means the angles don't change. And, like we just talked about, all of the lengths will be proportional. So if we had a mask where the distance between the eyes was an inch, and we held it halfway between the projector and the screen, so the screen is twice as far away, the projected image should have a distance of 2 inches between the eyes. Now this one was a little bit harder because we encountered it different ways with the masks and the transparencies, etc. But you probably got an innate sense of this. The farther away we are from the projector or the center of dilation, the bigger the projection became. So another way of talking about this is the fact that the distance from the center to the image, so this red shape here, so this big distance here, is proportional to the distance from the center to the pre-image. That's this distance here. So if I double the distance from the center to the image should become twice as big. And if I've specifically dilated it, for example, so that the image is 3 times as big, the image will be 3 times the distance away. So just to relate this back to the mask, the innate understanding you had, moving the mask closer to the projector made the face on the mask appear smaller, and moving the mask farther from the projector made the face on the mask appear bigger. So, that's all we have for today about dilations. We're going to be exploring dilations on the coordinate plane coming up in class. So if you have any questions about these basics, make sure you get those addressed in the beginning of class before we delve too much farther into other topics.